All right, good evening everyone. Hope everyone doing good. I hope everyone's day was good. All right, let's start. See how many people here watching live. Hopefully a few people will join in tonight. We got a Hyundai Santa Fe with the engine light and some issues with lymphoma mode, something like that. I haven't really looked into it, so we can all get into it and diagnose it tonight. I'll just give it a little bit of time, see anyone will join in. All right, we got John in the chat. John, how you doing, John? How was your day? Hopefully you had a good day. If my videos, audio, everything looking good, just give me a yes or no in the chat. John, thank you very much for joining in tonight. All right, John has a question here. John has a question. Yes, hello Josh. Josh, how are you doing? How's your day? John has a question. Holden Astra J2012 with a P0172 rich mixture fault code. Fuel trim, sorry, I'm trying to read this, John. Holden Astra with the P0172 rich mixture fault, fuel trim -20, airflow meter 2.4 grams per second at idle. If airflow meter is disconnected, fuel trim come back to normal. AFM Bosch. Okay, I don't know, John, is that a question or did you just wanted to throw that out there? Audio is good. That's good, John. Josh, how was your day, brother? How did you go today? Everything good? Had a good day? I hope, John, Josh. Rich mixture fault code -20 airflow meter. Audio is good. Okay, John, is that a question for us, or is that something you just wanted to throw it out, just so everyone knows that something you did today at work or something like that? Josh says good. That's good, brother. That's good. Are you aware of a problem with the airflow meter in those Holden Astra? I mean, not really specifically for Holden Astra, but obviously airflow can give you problems, something like you described. So what's the issue, John? What's the issue with the car? Have you sorted it out, or you're looking for answers? Alright, so who we got on the chat today? We got Joshua and John. That's about it today. I got 4 people watching at the moment. I'd love to see a little bit more before we get into this. Okay, John says P0172 rich mixture code. I mean, I had an Astra that recently, if it's a petrol Astra 1.8 or 1.6 liter, it had an issue with the evap system. So the purge solenoid was, I think that was throwing that similar fault code. I could be wrong, maybe it was lean mixture, not rich. I can't really recall that, John. Yeah, so purge solenoid definitely is a very common issue on them. They have issues with turbo cracked as well. Inside the turbo they crack if it's a turbo Astra, but that would probably give you a lean fault code. For the rich fault code, usually, yeah, mass airflow sensor can do that. Map sensor sometime maybe, even if it's got a map sensor. Basically, yeah, fuel pressure, injectors leaking, oxygen sensor. There's a lot of things. It's just hard to say. Just what you describe. It's hard to say. Okay, exactly what's gonna be. I don't know any common issues with them. Maybe Josh can chime in on that. Okay, Josh says just fixing cars today, no head stuff. That's good, brother. That's good. Joshua, are you home? Are you watching me? Do you have time? Joshua. .6 turbo. Those 1.6 turbo also has issue with the compression loss. If it's kind of misfiring in idle, and then when you rev it, the car's smooth, runs pretty well, not too bad, depending on how much compression loss is got. I've had multiple times that Astra's lost the compression and giving you that rough idle condition. Sometimes you have a rich fault code, not only that, you also get some misfire fault code as well. So that is very possible. Joshua just said PCV system, possibly PCV system is sucking some fumes from the engine maybe. Possible, but a lot of the time I think they give you lean code as well, Josh, PCV. But again, you never know with cars. When the airflow meter is disconnected, fuel trim are normal around -2. Yes, the PCB system is part of the rocker cover on the vehicle. So whenever the PCB system fails, you usually have to just buy the whole rocker cover assembly from dealer most of the time. When the airflow meter is disconnected, fuel trim are normal around -2. Now, is it because the airflow meter is the problem, or is it because the computer puts the car into a default strategy where it's just trying to protect itself, so everything, all the fuel trim, in fuel injection system, everything comes to kind of like a default safe mode? That is very possible too, John. You can't really just say that is the problem just because you disconnected it and everything come back to normal. You can't really go by that. You're gonna have to probably do some testing. At idle for a 1.6 liter turbo engine, it's pretty pretty good number there. You said 2.6 on the chat up there. The grams per second was 2.4. So 2.4 is a pretty good number. I would say a little bit lower than I wanted to see. Usually if it's a turbo car, I've seen grams per seconds. So this is how I've always learned. So this is just a ballpark figure. This is not exactly, you know, car specific, but universally mass airflow sensor reading should be, actually just show you on the board real quick, just if you want to remember in the future. I'll just show you on the board. Just give me 2 seconds. Hope everyone can see the board, right? So basically, that's pretty better, I hope. So basically, mass airflow sensor, MAF, right? Usually if you got a grams per second data on a scan tool, usually the universal sort of rough figure, what you want to see on them is exactly the size of the engine. So if you got a 1.6 liter engine, you want to see 1.6 grams per second at idle. Okay, this is at idle. So if it's a turbo, let's say if it's a 1.6 liter turbo, right, you probably want to see double that number. So 1.6 multiply that by 2 is about 3.2. Am I doing it right? So 1.5, yeah, around 3.2 grams per second on a turbo car. And I've tried this in many vehicles, and they all kind of line up around that figure. Obviously, depending on the health of the engine and, you know, the sensors, health of the sensor, mass airflow sensor and everything, there might be a little bit of variation up or down, but usually that's a pretty good number if you don't know the specific specification for the car you're working on. Okay, I hope everyone catch that. Okay, yeah. All right, anyway, let's get into it. We got a car today with the problem limp home mode. That's what the customers told me. The car is going into limp home mode. Cannot drive it. I simply drove from my my parking lot to the shop, right? That's all the driving I've done. So according to the customer, the car started losing power this morning as she was going to work, right? And then even in the afternoon when she brought the car over, she drove the car over and she said it's absolutely, there's no power and engine lights coming on. So that's the issue we're dealing with today. This is a Hyundai Santa Fe, okay? Hyundai Santa Fe 2013 model. It's got a diesel engine, so CRDI. So it's got a diesel engine, 2.2 liter, I believe, Hyundai Santa Fe. That's what we're dealing with today. And basically, like I said, I've only driven from the parking lot into inside the shop, and I can already feel the car is in limp home mode. It's stuck in, you know, higher gear, so there's no no power whatsoever when you're driving. So now the engine light is on. All right, what should we do first? Let's get some suggestion on the chat. What should we do now? We got the car, limp home mode, doesn't have power, engine light is on. What should we do? Okay, Joshua has just chimed in. I think that is for John. John's question regarding that Astra. Check your fuel pressure too. Man could have a regulator problem. So fuel regulator problem. So I'm not too sure, are they indirect injection or direct injection? I'm pretty sure 1.6 liters are direct injection, but I could be wrong. So that's another tip there for you, John, from Joshua. Thank you, Joshua. All right, Joshua has a comment saying pull false, and John also read fault code. All right, let's do that. Everyone wants to read the fault, so let me set up the scan tool and everything, and I will be back in 1 second. Okay, I got my scan tool on the screen. I've already selected the car and read the fault code for you guys, so that's all the fault code we got. All right, let's go into, so we got some faults on the ABS, and there's some faults on the engine computer as well. So we got one fault on the engine computer, and we got two faults on the airbag, sorry, not ABS, airbag. So those are the fault code. We got exhaust gas recirculation, EGR control circuits range performance. And we have battery voltage low on airbag, also driver's knee airbag resistance too high. Okay, I'm not too worried about the airbag light. Let me just actually quickly start the car and let's see if the airbag light is also on. Okay, we do not have an airbag currently on, and it also says history on the fault code here. Even on the engine fault code, it says history. Okay, so I'm not too worried about the airbag. Let's go to the engine computer. All right, exhaust gas recirculation control circuit range. So it looks like they're talking about the circuit fault code, not really a performance fault code. But what we can do, we can quickly search at the bottom here on the scan tool. There's a search bar, right? So I'm just going to quickly do a search, and let's see what definition we can get on the internet regarding this one. Okay, so Hyundai P0404 DTC. So it says code that's the engine control module detects, blah blah blah, right? There's a couple of videos there. We also have down here, if you look, Hyundai i40 P0404 EGR circuit. So it looks like they're talking about a circuit fault code here, not a performance type fault code. Okay, so we will be dealing with the fault code with the circuit. Okay, now from here, where do we go next? You guys can comment and let me know. I'll just follow what you guys want me to do. Let's diagnose this together. Okay, so we still only got 4 people watching, so I hope more people will join, but it is what it is. So what's the other suggestion you guys have I should do here? Next step. We got a fault code for EGR valve. Okay, John says live data. Okay, no problem. Let's go to live data if you want. Josh following, yep, data. Josh wants to see the data as well. No problem, guys. Let's go and look at this live data. Okay, so which data you want to see? Obviously, I believe you guys want to see EGR valve data, so let's go EGR valve. So I'll just type it in up here, EGR gas circulation actuator. We got too many fault codes, live data here. Okay, so what can we make out of this? I will briefly start the car and let's just watch how the data reacts. Matt, how are you, brother? I'm good, how are you? Okay, so let's start the car up. You guys can watch the data and see what it does. The car actually does drive, starts and runs pretty good, idles pretty good, so I don't see any issues there in that regard. All right, the car is running. Okay, we're seeing some activities on the EGR actuator. The percentage is going up and down a little bit. So it's moving from 0 to 30% actuator. And everything else kind of doing nothing. I'll just go and rev the car. So when I'm revving, as you can see, the data obviously goes to 0, the percentage of EGR circulation, then it jumps, when I come to idle, it jumps to 100 and then comes down to 0, 30%, it dropped to about 20, it's still at about 30%. Okay, that's what we're seeing. Let me go and rev it and let's see if other data do anything else. Okay, I did see the actuator position is going up and down as I'm revving. Actuator percentage, the rest of the data does not move. Alright, that's where we at right now. So where do we go next? Hello everyone. Hello Josh. Hello Matt. Matt said hello to Josh. Doing well, brother Matt. That's fantastic. That's the way. All right, where do we go next, guys? Let's get through this quickly if we can. Let's get this dealt with. Doing well, brother. Doing well. No problem. That's good, Matt. All right, the data pretty much shows that there's not much really happening there. Like on all the other fault codes at the bottom, it's not moving really, and my exhaust actuator percentage does go up and down as I'm revving the car up and down. So where do we go next? Alright, so before we do that, let me just quickly show you something on the scan tool that we can also do. Is let me go out to trouble codes again. Alright, so on the trouble codes, what we can do on this scan tool, this is Autel Ultra. Maybe your scan tool may not have this functionality, but on the Autel Ultra, what you can do is you can go to this spanner next to the fault code, right? And then you can go to data analysis, and sometimes it gives you this factory data, factory information. So receiving ECM signal, DC motor type, EGR actuator operates EGR valve directly. ECM performs EGR system feedback control with the information of measured mass airflow. Okay, so it takes the mass airflow sensor information in to control the EGR valve. The roles of mass airflow in diesel engine is different from gasoline engine. Okay, there we go. There's a difference in diesel and the gasoline engine for EGR operation. The computer has a different strategy. So fuel injection quantity is decided by mass airflow signal in gasoline engine, where when EGR gas contains no oxygen, flowing into the combustion chambers increases, the air passing through mass airflow sensor contains oxygen decreases. That's a pretty good information there. So basically what it's saying is fuel injection quantity is decided by mass airflow sensor, which we typically that's how it goes. We know that when EGR gas, exhaust gas coming into the combustion chamber, right, increases. So if you send the EGR gas into the combustion chamber, into the intake, let's say EGR valves opens, exhaust gas comes in, the air passing through the mass airflow sensor decreases. Okay, so that's a good valuable information. You can use that in the future for other diagnostic as well, I think. Thus, therefore, with the output signal change of mass airflow sensor accompanied by EGR actuator actuation, ECM determine the amount of recirculation gas, whatever that was, UNTT, I don't know what that means. So basically what it's saying is when the EGR valve opens, the mass airflow sensor reading decreases. So, and then computer calculates that by using how much it's trying to open the EGR valve. So that's how it knows how much exhaust gas is going into the intake. So the mass airflow sensor does the monitoring of the EGR flow. That's what it's trying to say here. Okay, so when the DTC is set, the particular DTC we're talking about, P0404, the EGR actuator is wide open or closed for more than 4 seconds. Okay, that's when the DTC comes in. Engine running, this gives you some, data. Their strategy there on detecting fault codes. EGR motor is stuck with opening or closing. EGR actuator motor temperature is high. I don't know how they know the motor temperature. Maybe they have temperature sensor in this EGR. I do not know. Fuel cut, yes, we have that fail-safe issue. So it cuts the fuel down. It goes into limp home fail-safe mode. EGR is turned off. Fuel limit is yes, and check engine light is on. Possible cause is EGR actuator motor circuit. So we know the fault code also describes a similar situation. We have an EGR circuit fault. Okay, that's where we at. Let's go back. Let's have a look at the freeze frame data quickly down at the bottom. Click on the freeze frame for that fault code. So the fault code is logged when the engine temperature was, let's say its engine was still cold, 48 degrees Celsius. Intake manifold is at 101 kPa, which is just at idle, I would say, because this is a turbo vehicle. It's at idle, so it's atmospheric pressure there. RPM, engine speed is at 834, which is again idle condition. Vehicle is not moving, it's 0 km per hour. And we got a few other data here, not really important, I would say. Maybe the mass airflow sensor data could be important, 16 grams per second. So that's when the fault code locks. So as soon as you at the start of the car, the fault code has locked. So that's what we can find here. Okay, that's just a little bit of a scan tool check there. So John Gonzalez special function EGR test. Okay, clear fault code, will it come back? We can try that too. So let's just do what John has requested first. Let's go to special function and do the EGR test. All right, active test on the scan tool. Let's go active test. And we're going to look for EGR circulation valve actuation here. So we got few fault codes here. Few active test here. Let me see what's on the special function. We got maybe engine test function. No, not that one. We want to go to active test. So we got two basically actuation here. We got EGR gas circulation, which is this one here, and we also have a EGR circulation valve data at the bottom here as well. So I'm going to start the car now, and let's see if we can do something. Let's see if we can actually do it, actuate it with the engine not running. Sometimes you can't do it, the engine has to be running, right? So let's try that. So I'll open this active test EGR circulation valve 5%. Okay, let's do that. Engine running condition, the engine has to be running. There you go. Continue time until stop button. Okay, I'm going to go start the car and we'll see what happens. Excuse me. All right, I'm going to hit start, and I don't know what I'm listening to, but I can hear the engine is getting a little bit rough. Okay. All right, let me try again. Stop. Let me try again. Stop. The first time I did it, that engine was getting a little bit rough, but not right now. Let me go the other way and let me try the 95%. The engine is trying to stall. It's trying to stall right there. Okay, you can see the engine shaking. It's trying to stall. Okay, I'm going to stop it. All right, engine comes back. The revs comes back good. All right, that's where we're at. So you guys saw that, right? The engine, when I did the active test, opened the EGR up 5% or 95%. There was two data. I don't know exactly, are they closing or are they actually opening 95% or 5%? We don't know that. But whatever the case, we did that, and now when I did that, the engine tried to stall and tried to shut down. It was very rough. And as soon as I turned off the active test for EGR, the engine come back smooth. So what does that tell you is right now the EGR system is working just fine. That's what I can say, because you're sending that exhaust gas into the engine and engine will try to stall because obviously it's exhaust gas, right? So the fuel ratio or whatever is not accurate for the engine condition. So right now looks like the EGR valve is working. All right, where do we go from here now? Ruben just joined in. Hello Ruben, how are you? Okay, so far looks like this EGR system is working. So where do you go next? Do you want to try what Joshua has recommended? Clear fault, will it come back? We can do that, but I don't believe it will come back. I think it's an intermittent issue. It only happens every now and then. But whenever it happens, computer will lock the fault code and put the car into a limp home mode. So that's what it looks like. John has says, look at the wiring diagram. It may be an intermittent fault related to temperature. Yep, no problem. That definitely is a possibility, John. So where do we go next? Do we still want to clear the fault code, Josh? Or do we want to move on to some different test? Because I'm pretty sure this fault code will not return if we clear the fault. Might be dirty, getting stuck. Yep, that is very possible. But according to the fault code, Josh, this is my understanding, is it's showing us a circuit fault code. It's not actually telling us it's a performance fault code. We could see probably a different fault code if it was a performance fault like that. it's getting stuck, because electrical part is still working, means computer shouldn't throw a circuit fault code. So I still believe there is a problem. In my opinion, is the EGR valve has some circuit issue in the coil, in that motor, intermittently. So that's what I'm looking at. Or you could have a faulty wiring as well. Every now and then it's, you know, not making good contact, or there's a, you know, break somewhere every now and then. So anything is possible when it comes to circuitry, but looking at the car, judging at the, you know, condition of the car, it's only what, 7-8 years old, so I don't know if the wiring is going to be our issue. I would say EGR maybe is the issue, and I have seen many times lately actually lighter model diesel cars, the EGR valve, they tend to only last about 7 to 10 years. You know, I've done many EGR valve, and it's always been the valve that's going bad between 7 to 10 years. So this car is at around 7-8 years, so maybe it just need a new valve, but we can do more testing if we like. So what's the suggestion here? Should we clear the fault code? Okay, let's clear the fault code just for fun anyway, but I'm pretty sure it's not going to come back. All right, let's go and clear the fault code. Alright, I'm going to clear that fault code P0404, so we will just maybe even quickly do a printout, so I'll have a record. Alright, I'll just print that out for myself. Now I'm going to clear the fault code. Let's go. Alright, fault code is gone. Let me try to read it again, see if the fault code comes back. The fault code hasn't come back. I'm going to go turn the car, cycle the key on and off, and maybe even start the car, and let's see if the fault code comes back. Alright, car is started. I don't see any engine light. The engine revs. The engine revs good. I got all my powers and on the throttle, you know, back on the acceleration. So let me try it one more time. Sometimes you have to cycle the key twice or start the car twice for the fault code to return. I've seen that in many cars. They don't lock the fault code until you cycle the key twice. Okay, let's do that. This is the second time I'm starting the car. Let's rev it up and down. No engine light so far. All right, I'm gonna just turn the car off now and go. Turn the car off now and then go back and check my scan tool again to see if the fault code has returned. Okay, the fault code has not returned. Okay, what do we do next now? What do we do? The fault code has not returned. Alright, what's next, guys? What should we do? The fault code didn't return. John has commented earlier, look at the wiring diagram if may be an intermittent fault related to temperature. Yeah, a lot of the time intermittent fault can be related to temperature as the temperature of the component increases. Yeah, like we said, they can definitely give you that issue. But what are we trying to find on the wiring diagram specifically, John? I can definitely pull up the wiring diagram. Can you explain to me what you want to see on the wiring diagram? Just so guys I know my audio, everything is coming clear, just let me know audio is good or not. I'm just using a wireless microphone, so sometimes there can be a problem. While you got John, let me know what he wants to see on the wiring diagram. I'll just try to see if I can find a wiring diagram. Not always we find all the information we need in Australia when it comes to automotive, info and wiring diagrams. So I'll try, see if we got the diagram here. John, EGR valve control. Yes, we kind of know already without looking at the wiring diagram where is the control is coming from, because this is just again universal most of the time. The two control wires for the EGR valve, John, I'm responding to John's question, EGR valve control. Most of the time EGR control directly comes from the ECU, so there's nothing else we have to check for fuse or relay or none of that stuff. Sound is good, thank you Josh for that. Okay, let me see if I can find a wiring diagram anyway. I already look at it and guess what, there is no wiring diagram. Okay, here we go. So I got the car selected, right, Hyundai whatever that is, wiring diagram, and we got nothing. Let me try again. So we go Hyundai, where that is. Hyundai, Sonata Santa Fe, wiring diagram. So we got 2.2 diesel. 2.2 diesel, so this is from 2015, so that's not gonna be right, but 2012 to 2015, this is a 2013 vehicle, that must be that one. And all we got is a AC, air conditioning wire diagram, that's it. That's all we have. So what are we gonna do here? What can we do, guys? That's all we have. That's all we have, guys. Okay, what should we do next? This is the problem in Australia. We can never find the information we need. Okay, what can we do next? Any suggestion? So that's why I like to teach a universal methods. Even if you don't have the wiring diagram, you can still diagnose cars. That's my approach most of the time. I don't even like to look at the wiring diagram unless it gets really complicated and I can't figure it out, some complicated issue. That's the only time I'm desperate to look at the wiring diagram. But most of the time, seriously, I do not look for wiring diagram, none of that stuff. I try to avoid that because of this exact reason, You don't know what type of car is going to come into your door, what year, model, we don't know, and we always not going to have the wiring diagram. So John Gonzalez has suggested a visual inspection. Joshua says EGR position sensor, can you see the valve? Let's look at it. I'm not sure where the valve is either on this system, so let me go and have a look here. Alright, let me try that. Alright, that's what we got here. We got the engine cover, right? So let's just pull that out the way. Okay, so let me just quickly eyeball here where everything, how the system is laid out. Okay, I can't really see everything properly here. Looks like there's an EGR cooler sitting at the bottom here below the air intake. EGR cooler, I can see the coolant hose and everything going in there. So that sort of comes in through there. The intake pipe comes up to the, sorry, the exhaust pipe comes up to the intake right here. Okay, so in my understanding, looks like this is our EGR valve, because the plug and the structure of the EGR valve looks like a EGR valve. Looks like they done it very cleverly. I don't know, I can't really see because it's so compact. I can't really see where all the piping and everything is. Looks like the exhaust, from the exhaust gas actually comes through the head into the valve, and looks like from the valve it goes to the front of the car again through the valve, through the head, right? There's no external piping I can see, and then it goes down to the EGR valve, EGR cooler in this area, and then comes up to the intake manifold. Looks like that's the design here without taking everything out. Like I said, I can't see everything here. All I can see is this valve. It's got a big plug on it. Looks like 1, 2, 3. Looks like it's got 5 wires. Okay, it's got 5 wires, which is typical EGR circuit. 5 wires, and that's what we have here. Okay, so I'll just grab this camera and I can quickly show you the visual inspection like John wanted me to do. So basically, that's the plug for the EGR valve. That's where it is. That's your exhaust, obviously. There's no piping between the exhaust and the valve. Looks like it's done through inside the head. Okay, there should be a tunnel in there. Anyway, that's a EGR valve. Looking at it visually, I don't see anything wiring been chewed or mice been getting in there. Sort of wiring comes out this way, comes down, you know. I don't really like how it's touching that plastic cover there, but again, I don't think it's still kind of insulated pretty good. Then it goes, the wiring goes towards the front, and then it goes down into the harness. So doesn't really look like anything suspicious here, wiring wise being damaged. Okay, everything looks pretty intact. Like I said, the car looks like has been looked after. It's pretty clean and it's not very old. So that's where we're at. Okay, what's next? What do you guys suggest we should do here? Joshua says EGR position sensor. Can you see the valve? Yes, we can see the valve. It's sort of sitting on the top of the engine. Do some testing. Okay, what tests can we do here? Can someone tell me? Anyone has a suggestion? How can we? We don't have a wiring diagram. Like I said, there is no wiring diagram, right? And there's 5 wires in that connector for the EGR valve. Let's see how many people can tell me what we gotta do here, what we can see without a wiring diagram. Let's tackle this together. Alright, that's the plug for it right there. I'll try to get a better angle here if I could for you guys. Alright, that's the wiring plug right there. There's 5 wires going in there. Okay. I'll just get that clip off. Alright, I broke it, but doesn't matter. Alright, that's where we're at, guys. What do you guys suggest to do next? Okay, John has commented, just a guess, 3 wires for the position sensor and 2 for the motor. Okay. That definitely sounds true to me, but let's hear from others quickly. Okay, any other comments, any other suggestion? What can we do at this stage? Also, do me a favor, guys, just like the videos, thumbs up. Just under your video you'll see a thumbs up sign. Just hit that button. I've heard that that actually helps with the YouTube, how they present my videos to other people as well. So hit that like button, help me out, brothers. Motor might have two 12-volt ground, 5-volt and 5-volt signal. Okay, Joshua has commented, motor might have two 12-volt and then ground, 5-volt and 5-volt signal duty cycle. Yep, that's definitely something I would say. That's what it's going to look like. Like I said, we don't have any wiring diagram, so we can't do much here. So let's do that. How about we go to the board quickly, and I'll quickly try and explain what we expect, and then we can go and do some testing. All right, let's go to the board. Just let me know if you guys can see everything clearly here. Okay, so let me just get rid of that. Okay, so EGR valve, right? So we got EGR valve. Let's do some. So this is a modern EGR valve, mostly on a diesel car, and this is universally, I've seen it on many EGR, diesel cars. It's the same system. And Navara, BT50 Rangers, excuse me, X-Trials, and even Hyundais today, it looks like it's the same system. Now I'll give you a universal, ways of testing and looking at the wiring and getting to know the circuitry. But again, I could be wrong. Then what we'll find out once we go to the car and see what we find there, right? So EGR valve, we saw 5 wires, right? So usually I have seen they all have 5 wires on the EGR system. So we know the EGR valve, the modern EGR valve has two components. One is a position sensor, right? So it will probably be called EGR position sensor, right? And then it's going to have an EGR valve, which is going to be controlled by a motor, right? Let's say EGR motor. And this is controlled duty cycle by directly ECU. Okay, so that's the percentage you're seeing on the scan tool. That's the actuation percentage of the EGR motor. The computer decides how much to turn it on and off. Okay, everyone's following so far. Ignition on and off. Matt has a comment, ignition on and off, and say if it is cycling. Yep, definitely. That's a great comment there. So what Matt has said is, when you turn the ignition on and off, usually the EGR valve computer like to reset it. So you probably see some activities on that motor when you turn the ignition on, then off, or just when you're turning it on, they usually like to do that resetting or whatever the computer does. Okay, I don't know, I'm not the engineer, I can only tell you what I see. So that's definitely a good way of testing it, but is that motor working? We don't know that. So for that one, we might need a scan tool or a scope, right? Maybe a scope that will tell us the wiring is good, the control is good, and everything. Okay, so we got EGR position sensor and the motor. Okay, let's get everything out of the way. Only focus on position sensor, and we're going to focus on motor. Those are the two components we're going to see on the EGR valve. Okay, so let's talk about the motor. So what does a motor need to operate? A motor is, anything is a motor. Let's say any components that's got motor on it, pump, fuel pump, blower motor, you got window motor, we got cooling fan, headlight bulbs, all these consumers that use electricity to function, and it does something in the output, as in if you put power and earth on a fan, the fan's going to turn, right? If you put power and earth on a motor probably going to spin. If you put a power and earth on a solenoid's going to move. If you put power and earth on the injector's going to move, open and close. So if you put power and earth on a headlight bulb, the light's going to light up. So the consumer, the output, got its job, and it has a job to do. But what does any consumer and any output needs to function? It needs power and earth. That's it. So it needs power, positive, and it's going to need earth. That's it. 2 wires. So 2 wires can function any component, any output or consumer, right? So out of 5 wires, we already know 2 wires is going to be our motor control for the EGR in this case. Okay, and on a position sensor, let's say go position sensor, how many wire does a position sensor needs to work? Right, it needs 3 wire. Right, so it needs 3 wire to operate. So what does the position sensor need to work? You're probably going to see a 5 volt. You're probably going to see another 5 volt bias or 0 volts sometime. And you're going to need an earth. So we're going to need 3 wires to make a position sensor work, right? 2 and a 3 wire. Okay, so that's total of 5 wires in that connector, 2 for the motor, 3 for the position sensor. All right, if you have that, call it a valve, and I'm going to have a shower. If you have that, call it a valve. Okay, no problem, Joshua. Ruben says 3 wires. Yes, that's 3 wire for the position sensor. Okay, so let me just get a little bit into the position sensor real quick. I think some of you guys there have already spoke about this in the past with you guys, but someone new want to watch, I'll just describe that anyway. So we're going to have an ECU, right? This is your ECU. So the ECU is going to have 3 wires coming out for the position sensor. So we're going to have 1, 2, and 3 wires coming out. Position sensor, I don't care how they built it. I don't care what's inside. I'm not interested. Okay? Now, what you're going to see is you're going to see a 5 volt power supply, which is going to come through the computer, some power, 5 volt power source, right? 5 volt reference. And then we're going to need an earth. You're going to see an earth on one of the wire, which is going to go maybe, probably inside the computer, the earth, right? And then what we're going to have here is maybe 5 volt most of the time, or 0 volt. This is a bias voltage, if there is a bias. And this is your reference voltage, if there's a reference, right? And it's going to go in there, and computer is going to do its measurement somewhere in there. Let's put a voltmeter there to do its measurement. And then if there is a bias voltage, you're going to have a resistor between the signal and the 5 volt wire. If there is no bias voltage, there is no resistor in there. Okay, that's the only difference. This is a position sensor, typical position sensor. There's no difference to pressure sensor. Pressure sensor works exactly the same. I think we discussed on that live video last time when we were doing pressure sensor on a mass airflow sensor on that Mitsubishi, right? So this is what you're going to see. And the motor, positive and negative, 2 wires, going to also be coming from engine ECU, right? So let's build another wiring diagram here. It's an ECU. Let's say this is your engine computer. You're going to have 2 wires coming out, and this is your motor. So what you're going to see, because like I discussed up here, you're going to need power and earth to operate that motor, right? So it's going to be power and earth, and I would say more than likely they will be switching between wires to move the motor this way or that way, okay? Whichever way direction they're going to move that motor and the valve. And they're going to have some kind of power source here. However computer does it inside, we don't care, we don't know. What we care is what you're going to see at the motor. Okay. Now, once we know all this, we should be able to go in there and figure it out exactly out of that 5 wires, which one is our position sensor wires and which one is our ECU, which one is our motor control wire, right? Okay, so if my wiring diagram is correct, those are the wires. Pin 1 motor control positive, pin 2 empty, pin 3 motor control negative, pin 4 signal, pin 5 sensor ground, pin 6 sensor 5-volt supply. Yep, that sounds right to me, John. That's definitely sound right to me. Looking at the wiring plug, that definitely sounds right, because I've seen, like I discussed last time too, they will arrange the wiring in an order where one component wiring will be, you know, together. So looking at this wiring plug, let me disconnect that real quick. Okay, that's disconnected, and as you can see, according to John's wiring diagram, we got on the top here green and the kind of like orange, green and orange at the top. The middle one is missing, like exactly what John said, and on the bottom, I'll just turn it around, we got red, blue and a yellow wire together. So if you ask me, I would say the bottom 3 will be for my position sensor and the top 2 will be for my motor control. Okay, having a wiring diagram is great, but like I said, if I was doing this diagnosis myself, I would not even bother looking at the wiring diagram. As soon as I put some meter on it, scope on it, I already know which wire is for what. Okay, so that's where we're at. Okay, so far everyone's following. How is it going, Matt? How is it going, Ruben? I know John is taking it in. Thank you for pulling up the wiring diagram to help me out. Definitely helpful there. But like I said, I like to keep it very universal, so you know, people on the field like me today, I don't have any wiring diagram, I can still do all my testing without having to have a wiring diagram. That's my intention anyway. All right, any comment, suggestion? Matt, are you following? Everyone's following. I think Josh disappeared on us. All right, Ruben is following. Fantastic, fantastic. All right, Ruben, where should we go next? What do you suggest here? Joshua is here, no problem. Thank you, Josh. I am pretty sure, Josh, you already know this stuff, so it might be a little bit boring for you, but again, there could be other people definitely want to learn this sort of stuff, I hope. All right, Ruben, what should we do next? Okay, in my opinion, I think we should just pull up a scope, maybe even multimeter, and let's let's get into it. Let's do some testing, and let's figure it out what we can find. Okay, so let me grab my multimeter. As a lot of the time, what I've found is once you know most of the basics, a lot of the time it's pretty similar testing. Like I said, there's not many sensors in the cars. There's like 7, 8, 9 different types of sensors. As long as you know all the basic how they work, this stuff sort of gets pretty easy. Not saying everything is easy, not saying every time it's going to be easy. There could be times where it's a really difficult problem. It just doesn't make sense. It's just, fun when it comes to diagnosis, right? But most of the time, sensors testing, component testings are pretty easy. There's not many there. So it might even look like I'm repeating myself again and again, but this is our trade. So more you practice, more you learn. Okay, test the plug. Okay, Ruben, let's test the plug. Okay, what are we going to see here? We're going to see 5 volt, 0 volt, and 1 volt. And 5 volt, and earth. Okay, that's a position sensor. All right, so let's go to the plug. All right, I got my multimeter. Let's just start with the basic stuff, right? Just use a multimeter for now. And then we can even put a scope if we have to later, if you want to. Okay, I'll just leave that there. You can see the meter. I'm on a voltage scale. Battery negative on my test lead. And let's go and find the wiring. So like we suspected, the top 2 probably is our motor, and bottom 3 is going to be my position sensor. So let's just gently touch that terminals without damaging it or spreading it, right? So let's go. What we got? We got 5 volt on my red wire. We got nothing on the middle wire. And we got 4.74 in my yellow wire. So, okay, we got 5 red wire, 0 blue wire, and another 5 on yellow wire. Now the middle one, which is showing 0 on the meter at the moment, I'm pretty sure that's our earth. So let's test that. Okay, because multimeter is not going to tell you if it's an earth or nothing. They're only going to show you 0 most of the time, right? All right, I grab my test light, put it to battery positive this time because we're looking for earth, right? So let's connect that to battery positive. Now when I find earth, this test light is going to light up just like that. And we said the middle one, which is our blue wire, is going to be my power. Sorry, the earth, right? There we go. We got the earth in the middle wire. So there's no difference like we always discuss on 3-wire sensor. 5, 5, and earth. Okay? Now that's verified. Now I'm going to show you this too. So I got on those other 2 wires at the bottom, right, the red is my 5 volt on the screen, you can see, and the other one is a 4.75. Okay, if we understand everything, if we're following me for a while, can someone tell me which one is my bias voltage and which one is my reference voltage there? All right, I know you guys already know this. You should know this. Can you tell me which one is my bias voltage and which one is my reference voltage? 4.7 is my signal. Yes, that's the signal wire. 4.7 is a bias. Yes, Ruben, you're following me. I'm glad. So let's go back to John's Gonzalez comment there quickly. So what John has said is, let me just try that. Okay, there you go. Let's go back. So John has said, if my wiring diagram is correct, they are the wires. These are the wires. Pin 1, pin 2, we haven't checked the motor control yet. So the pin 3, motor control negative, pin 4 signal, and pin 5 ground. Sorry, hang on. Pin 4 is a signal, pin 5 is a ground, and pin 6 is a 5 volt. So 4, 5, 6, signal, ground, 5 volt. Let's see. I can see some numbers on that plug, right? Let me see. Sorry to disappoint you, John. Your wiring diagram is not right. So pin 1 is my 5 volt reference, pin 5 is my ground for the sensor, and pin 6 is my signal for the sensor. That's what it looks like here. There you go, John. John's replied 4.75 is a signal. Yes, and 5 volt supply. And we all understand why there is a little bit of voltage drop, right? I know you guys already know, but just for other audience, I want to quickly explain to them for them on the board quickly, if you don't mind, okay? I know I'm doing it all live, so it's not going to be smooth, quick, so just bear with me, guys. All right, so basically we saw with the connector disconnected on the position sensor, right here, with the connector disconnected right here, we saw 5 volt on that solid. That's our reference supply voltage for the sensor to do its job, right? We got earth, no problem there. We saw earth, test light lights up. But on the bias voltage we saw 4.7 or 4.8, something like that voltage. There's a voltage drop of a tiny fraction, little bit. Even when we're learning, they say look for 5 on earth. It's not always going to be 5 on the bias voltage. Okay, they're going to be voltage drop. The reason the voltage dropping is this 5 volt is traveling down this way. Obviously this goes to my supply, but also there's a resistor. It comes through the resistor and travels that way. That's why you're only seeing 4.7. There's a voltage drop right here on that resistor, which is inside the computer. This is all happening inside the computer. Okay, so this is just for the other viewers who wants to know this stuff, like I said. Okay, all right, where should we go next? All right, I think we should start checking the other 2 wires. Let's see what we see with the sensor disconnected, right? And then from there we will probably do some scope testing, okay? Same with the scope. Before we go to the motor, let's just quickly do the scope here, right? So, good. All right, we got a comment here from Joshua. Doing a good job by yourself, man. Thanks for giving your time. Yeah, thanks, Josh. Thank you so much. Josh, you need to come here one day and we can do the session together. I really will enjoy to collaborate with you. Matt, Ruben as well, we can do a collaboration as well. Thank you, Josh, for that comment. All right, let me just set up my scope quickly, and then we go from there. We'll do some testing on the sensor. Okay, so we've got a scope there. Alright, my scope is set. Alright, I just want to bring both the screen there so I can do the testing and everything at the same time. Before I do that, let me just quickly check the comments. Joshua doing a good job. Yeah, that's good, no problem. Alright, let's go to the scope now and then we'll do some testing. Okay, on the scope, let's set the voltage level here. Let's go plus minus 20 volt. That should be able to show us everything. This is only going to be 5 volt signal for the position sensor, right? Let's go time base wise. We don't need a very fast signal. We just go 1 second. All right. Okay guys, we got my scope ready to rock and roll here. Okay, my channel A, blue channel, to battery negative, and I'm just gonna go and look for that same power, earth, everything on that. We're just gonna do the same thing on the scope. There's no difference. Okay, so let's go to my first wire, which is red one. We say it was 5 volt. Let's put it in, and you can see on the screen just above 4 volt, right? So it's a 5 volt. Now let's go to my second wire is the earth. We don't need to test that because if you put on that, you're only going to see 0 volt on the screen anyway, so that's not going to tell you much. You need a test light to check that earth every time. Okay, just 0 doesn't mean it's earth always. 0 could means open, 0 could means nothing there. So always use a test light for checking earth. Now first wire, red one, is a 5 volt, you can see on the screen. Middle one is my earth, and the third one, yellow wire, is my 4.7. And as you can see, there's a voltage difference there as well. Okay, you can also pick that up on the scope. So let me go back quickly, and I'll bring that cursor down. It will measure the voltage for me. All right, right there we got 4.98. I'm not very accurate there, but about 5 volt right there. So as you can see, there's a 5 volt up on the screen where I'm measuring. Let me bring the other one and I'll put it right there where my yellow wire, the signal wire voltage was. And you can see, obviously I'm not lining up very good here, but so this one's showing me even less voltage, 3.3. Let me actually do it again so we all can follow this. There shouldn't be 3 volts, 3 volt there. So let me bring that down to about 10 volt range so we can see a bigger picture. Let me just quickly do that again. So we got red 5 volt, right? And then we got red 5 volt, we got 0 volt, and we also got the signal voltage. All right, let me pause that and let's measure that voltage again. So we got 5 on that first bit when I put that on the 5 volt reference wire. Then we got 0 at the bottom here when I put it on the earth wire, and that's my signal wire. Okay, that's even looking less than 4.7 volt we saw on the meter. Okay, definitely the scope is not telling me right voltage there for some reason. So let me just quickly try it with the multimeter, make sure I'm still getting the same voltage. 4.7 on the meter, I'm still seeing 4.7, but the scope is showing a little bit less. But anyway, it doesn't really matter. Maybe my my earth wasn't connected very well. But that's a little bit strange why it would show less voltage than what it is. Anyway, so 5 volt earth, and yeah, it's still only sitting around 3.47 volt. That's strange. That is very strange. Let me go back again. Yeah, it's less than what I wanted to see on the scope. I don't know, for some reason it's not. It's because I am very, very close to that line, and I'm only seeing 3.7 volt, 3.45 volts. Okay, not sure why it's like that, but you guys got the idea. You guys got the idea what we're looking at here. Anyway, so that's my excuse me, position sensor. They're all functioning just good, right? So now next thing what we can do is we can put that scope in there, and let's see if that voltage drops. Okay, if our position sensor working, everything working in the EGR valve, that voltage should drop or increase depending on the position of the EGR valve currently. Okay, sitting where the position of the EGR valve sitting right now. Okay, so let's do that. So I'm gonna go and I'm gonna back probe that signal wire, which is my yellow wire. Okay. And I'm gonna connect that plug. So as soon as I connect, the voltage comes up to 3.9 volt. So if I start the car right now, we can see on the scope that voltage will jump up and down or reduce or increase depending on the EGR valve. So I'm going to go and do that quickly. There you go, you have it. I started the car and I rev it up and down, and you can see the position is changing on that position sensor. Let me go back. As you can see, as I'm revving the car up and down, the position is changing. So we know position sensor is working in this car. So it's just went from 4 volts somewhere there to about 1.5 volts. So it's range up and down, 4 and 1.5 volt. That's where we're at. Okay, so we know it's working, the position sensor is working. Is the scope dragging down the bias? I don't think so. Usually the scope shouldn't drag the wiring down like that. I've actually never seen something like that, but that was a little bit strange. Let me go back and see if I can try that again, because I don't believe that 3.7 volt is the right number. Maybe the voltage on the battery is getting low because the car's been ignition on for a while, maybe, but the meter shows differently though, so I don't believe that. Okay, so currently it's sitting at 4 volt with the connector connected, ignition on obviously. All right, now the connector is disconnected. Let me go and measure that voltage. It's still sitting below 4 volt. It's still 3.5. I don't know what's happening here. Let me see if I can change this lead. Maybe there's an issue with the lead. I'm not too sure. Let me try that anyway, quickly. Alright, I'll just grab a channel 2 and let's see what the channel 2 shows us on a different lead, different channel. So let's go plus minus 10 volt here, channel 2. Okay. Alright, let's try the channel 2. That is rather strange, but alright, on a yellow wire again. Okay, we got, let me measure that voltage. Nah, still same voltage. Still same voltage. Let me change the earth, if that makes any difference. Nah, I changed the earth. Still does the same thing. No, still same. Still 3.4 volt. I cannot explain to you why it's happening. I can restart my scope just in case something's went wrong there. Let me try that quickly. Okay, my scope is on again. Let me set the voltage and time scale again. Let's go 10 volt on my blue channel. On the same wire again. That's definitely 3.4 volt. It must be the scope dragging that voltage down. That's all I can think of here. Okay, let's read that meter again. Even on the meter with the scope connected, you can see, right? On the meter with the scope connected, I'm seeing 3.3 volt, like the scope. Okay? So it must be the scope dragging that voltage down. Okay, I've never actually seen this before, but I've heard it can happen, but I've never actually seen it before. But there we go. Now let me disconnect the scope and let's see if that voltage jumps up on the screen quickly, right? So it's currently 3.3 with the scope connected. Let me let me disconnect the scope, negative lead, and just put the multimeter. And then I'll just disconnect the scope completely from the picture. This is purely just the multimeter. Okay, 4.7, it jumps up. So it must be the scope, Josh, you are right. It must be the scope. Just that circuit is very, very weak. That 5 volt bias must be so weak, even the scope is dragging it down. That's amazing to see. Okay, so definitely every day you see something new here. That's amazing. All right, we got some comments. On signal wire, the impedance of the tester will change the voltage reading. Yeah, definitely. That's what's happening here, John. Yeah. Okay, is the scope dragging down the bias? Yes, looks like it. On signal wire, the impedance of the tester will change the voltage reading. Definitely. Definitely. Where we at? Where we at? Impedance tester will change the, yep, I think that is the reason. Yep, cool. Can you feed power to the, Joshua has a comment here. Can you feed power to the valve and see if you can hear it. We should be able to hear it. We know that at the moment the valve is working, so we should be able to hear it. I can do that for you after we do some testing on the signal motor control, the motor control wire. You can see the voltage drop when you connect. Yes, that's right. The load of the scope on the signal circuit is higher than the voltmeter. The voltmeter normally has a 10 mega ohm impedance and the scope around 2 mega ohm impedance. Yep, definitely, that is definitely the case, John, here. But I've never actually physically seen all the testing I've ever done on the cars. I've never actually physically seen that happen on the scope. Maybe this circuit on this particular Hyundai is definitely a little bit weaker voltage, I would say. It can definitely drop it, but not this much. I've never seen this much of a drop. Anyway, because if the scope gonna drop voltage like that much, and we're trying to test it, right? We're trying to test the circuit voltage reading for the sensor when it's working. Now it's gonna be a problem, isn't it? Because the voltage on the sensor has to range from 0 to 5, or when it's connected, that doesn't really matter because the scope is seeing the voltage from the sensor traveling through the supply wire. Okay, let me just quickly show you on the board what I'm talking about here. So basically what I'm talking about, and what John is talking about here, is the voltage drop we saw on that bias wire on the scope is because the scope obviously gonna drop that, the meter is gonna drop that voltage, right? Because what we're doing is we're putting meter on this bias voltage right here, which we're expecting 4.7, that's what we saw on the meter, but the scope is dropping it down to 3.4 volt. So what I was saying is that a problem, right? Is that a problem when we're actually doing some testing with the scope on that sensor? When sensor is changing the voltage, making the signal, is that going to reflect on the scope? But I know that statement is wrong, because when the sensor is actually working, everything is connected, and we're trying to get the signal out of the bias, the signal wire, the bias voltage wire, right? These 5 volts going to come back into this wire, if you follow me. This reference 5 volts going to, do its job. The sensor is gonna, do its job, and drop or increase, drop voltage or whatever it's gonna do, and that's going to travel through this signal wire back. So when we're checking at the connector right here with the scope, this drop of voltage on the bias voltage we saw when it's disconnected is not going to be an effect. I hope everybody followed what I just said. If I'm correct, John, if I'm incorrect, John, you can correct me. What I just explained on the board is a true phenomena. How much do you have on the battery? DJ, hello DJ, how you doing today? DJ, welcome. Matt, how much do you have on the battery? Sorry, what battery are we talking about, Matt? On what? Which battery? Are we talking about the car battery, the voltage on the car battery? Is that what you're talking about, Matt? I can show you quickly. We can check that, no problem. All right, we'll just test in the battery voltage real quick, guys. Just Matt has asked. We got 11.9 volts. So definitely the battery voltage is getting a little bit weak because it's been on for the last couple of 2 hours maybe. That could definitely be an issue, but I think it's just the scope dragging that voltage down. In my opinion, Matt, if that's the answer you wanted to ask, is that the question you wanted to ask? How much do you have on the battery? Yeah, that's what I think, Matt. It's 11 point something volt. Is definitely low. Okay, so let's move on to our motor control now, and then let's see what we find there. All right, so basically my intention today is, right, even without the wiring diagram, we can do all this testing just by looking at the wiring and the system. That's all my, because now we're down to 2 wires. We already verified and how they work and everything on that 3 wires for the position sensor. Without looking at the wiring diagram, we don't have a wiring diagram, we can tell and do absolutely without wiring diagram when it comes to sensor testing, right? Now we're left with 2 wires, the top 2, which is my green and the orange. So on this one, like I explained to you on the board, the green and orange going to be my power and earth for the motor control. The motor needs power and earth, that's it. Okay, any motor in the world is gonna need power and earth to operate, right? So how they're going to do is the computer is going to send power and earth, and they're going to switch between the wires to turn the motor on one way or another way. Okay, so let's do that. Let me just, I'll probably do this connected, but before that, let's just see if there's any voltage, anything coming on that sensor while the on that EGR valve while the connector is disconnected. Let me just see if there's any voltage or anything on those 2 motor control wire. Okay. All right. That is my green wire. We have 11.9 volt, and on my other in my other wire for the motor control, also 11.89 volt. This battery is definitely getting weak. So both the wires has, let's say, 12 volt. The battery voltage on it. We did disconnect it. Let me see if it is actually a true voltage. Can I put test light on it and light it up? If it lights up, we know the 12 volt is there all the time with the battery disconnected. Or is it some kind of just the monitoring voltage, like a bias voltage? Let's just figure that out quickly. Okay, so I'm connected to battery negative. When I find earth, this test light is going to light up just like that. So let's go and see if those 2 wires on the motor control, the 12 volts are true. Okay, I got 12 volt on that. The test light is lighting up, and I also got 12 volt on that, and the test light is lighting up. Okay, so what's going to happen here is the computer is going to send power on both the wire, and whenever it wants to control, it's going to send earth on one of them wire, basically, like I explained to you on the board earlier. That's how it works. Okay, so the Navara I did other day, the video, it had earth on both wire at all the time when it's disconnected. But this one's opposite. It has positive all the time, but doesn't matter. The switching is the negative. On the Navara, which had earth all the time, the positive is the switching. Okay, there's no difference here, really. Okay, I'm going to connect that now, and I'm going to back probe it, and let's see what kind of signal we get on the scope. Okay, I'm going to connect my channel A, the blue channel, on my orange wire. Let me set my scope up as well. And my channel 2, the red channel, is going to go to my green wire in this case. Okay, let's go on the screen and let's see what we got. Make sure my leads are not touching each other, right? So 2 wires left, right? We verified 3 wires, 2 wires left, which is our motor control. One, both has power. 12 volt supply on both wire when the connector is off. Now I connected it back on, got 2 channel on each wire, and then we're going to go up on the screen and let's see what we got. On the scope, right, we got 12 volt on both the wire. Let me just drag that down so you can see that 12 volt. Battery voltage is a little bit low, guys, but you know, it might not be exactly 12 or the battery voltage, but a little bit low, but you can see both sitting on the 12 volt mark. 12 volt on the blue, 12 volt on the red. Now I'm going to go and start the car and let's see what you got. As you can see on the screen, my scope is doing its job. It's getting all the signal for me. Let me change that time base. Let me increase that time base a little bit so we can see a little bit better what's going on there. It's going to be a duty cycle, right? So that's how it's going to be. The blue channel is, I'll just drag that down a bit so we can see that as well. My red channel is not doing much at the moment, but the blue channel is definitely duty cycle there. I'll just pause that quickly. You can see it's a duty cycle. So basically, if you follow my cursors, let me just zoom that a little bit more. So if you follow my cursors, when there's 12 volt present, the valve is not doing anything, computer is not sending control. When it drops to ground, you can see it's 0 here. Ground, sorry, let me go back. Ground, that's how much it's sending, you know, power or controlling the motor. So very little duty cycle here compared to, you know, off time. This is a on time, that's your off time. So very small duty cycle, but the red channel has no control at this stage. Okay, so now you can see the red channel is working. So I'm gonna go and rev the car up and down. You can see maybe both channel doing the control. Okay, let me just keep it there. You can see now I'm gonna go and rev the car up and down a little bit, make a little bit of change on the EGR valve. Okay, here we go. I'm revving the car now. You can see both my leads, both my control wires are getting the signal, the control from the computer to control that EGR valve. Even after I turn the ignition off and on, you can see it's doing some controlling there to reset or for the next time when the car starts, whatever. Right? So that's what we're gonna see on that motor control. So far I don't see any fault in the circuitry of the EGR system. Position sensor is good, motor control is good. I would say this is purely going to be an EGR intermittent issue because the fault code hasn't come back, right? So it's definitely going to be an EGR issue. The customer is going to need a new EGR valve in this car. Okay, so all right, that's almost the end of the video, I guess, for EGR valve today. Is there any question, answer, anything you would like me to do, anything you want me to test and show you? Please do comment. Okay, let me just quickly go and see if my fault code has returned. We've been starting and running this car a little bit, so let's just read that fault code again. Yes, my fault code has come back, but I think we set that fault code by disconnecting that sensor. See how it says sensor A circuit high? So it's showing me the it's showing me the position sensor fault code, which is we created that fault code. So ignore that fault code. EGR sensor A circuit high. So sensor A must be the position sensor. We can quickly search it and see what the sensor A means, right? We can Google that real quick. Sometimes scan tool don't give you the proper meaning of the fault codes, and sometimes you can't find it on the Google as well. So that's the fun part about diagnosing. You never know what extent you have to go to diagnose cars sometimes. Okay, there's nothing here I can really see quickly. So we can also go to our DTC analysis. Let's see what it says. Okay, right here you can read, right? DTC information P0406 is set when feedback easier valve position is out of low limit. So that's exactly right. So that's setting a fault code for position sensor. You can read right there on the DTC. So even if the scan tool says circuit A, we don't know what A, sensor A means, but the description, if you go into the scan tool data analysis or DTC analysis, you can sometimes find that information. Okay, so let me come back to that and let me read some comments here. DJ has sent a comment. Did you test the resistance on the EGR valve? I have not tested the resistance on the EGR valve, DJ. I don't usually do that sort of testing. I don't even trust those resistance tests. Sometimes resistance could be good, but the valve is still bad. I have seen that too. So you can quickly verify if it's open circuit or not, or short circuit or not, by resistance test. But I mean, it's a basic test. Everyone can do it. You can do it too. I'm personally not a fan of resistance test. When it's on the bench, yeah, I can quickly, see if it's open circuit fault all the time. As soon as you clear the fault code comes back on. In those cases, if I don't see anything wrong with the wiring and the control and the voltages that coming to the valve or the sensor, if everything is there and I don't have any other choice, maybe then I'll go and look into the resistance of the valve. So that's just me, but yeah, resistance can be a good test too if you want to just do that. If you only got a multimeter, if you just want to quickly verify the circuit, yeah, that's a great test as well. Okay, so what do we got here? We got can you check the EGR motor resistance? Same thing. If you guys want me to show you quickly, that's fine, for reference for the future, right? That's fine, I can do that. Motor can jam and cause a circuit fault, can it? Motor can jam and cause the circuit fault, can it? I don't think so, Josh. I do not believe so, because doesn't matter even if the motor is jammed, but they still should have some continuity to the computer, so the computer might not recognize that circuit fault. If it's open or short, maybe in the coil, in the motor, maybe that can set a fault code, but just having a jammed motor, I don't know, I don't think so. Maybe you'll see some kind of performance fault, not really a circuit fault, but that's just my understanding, Josh. Okay, so we got to see if there is an open on the valve. Sorry, I logged in late. If you did, do worry, we'll watch the video over. If you did, do worry, you will. Yes, so open or short in the components, yes, definitely a good test for resistance, but most of the time, I personally don't do that. That's not my first go-to test when I don't know diagnosis, but I do that test when I need to. Okay. From a stock valve. Okay, from a stock valve, okay, the motor is going to be jammed. Maybe computer can see a high amperage, maybe. That is possible, but again, how did they design the computer, what they monitor, we don't know. But maybe if they can pick up that, you know, high amperage on that circuit, but do they check the amperes on that circuit for monitoring? I don't know. I don't think so, but something that's possible. I do not know. Thank you. Matt says, thank you, Japan. Great job. No problem at all, Matt. Anytime. Anytime. All right. All right. Any last thoughts? Any comments? Any question? Everything? Before we, you know, close the session. Okay. Just quickly, DJ and John has asked the resistance value of that motor. I can quickly do that. I know you're not going to see anything wrong at this stage, because if there's an issue with the motor resistance, right? Let's say the resistance, if the circuit is open, the coil is open or shorted, I would say the computer will throw that fault code straight away. But this is an intermittent problem. We might not see that at all. But I'll go and have a quick look at it, just so we know what type of resistance we expect on a Hyundai Santa Fe 2013 diesel EGR valve. Okay. Okay, let me go back here. Let me put the mirror. Let me disconnect the cable. The connector. All right, I'll get the leads out the way. It's a little bit difficult to get to it too. That's another thing when you're doing testing on a compact engine like this. We could probably back probe it and turn the key off, but as you could see, the computer was controlling, so it's not a great idea to do a resistance test with the connector connected. You don't know what the computer is like, what the design inside the computer. So we're gonna have to do it disconnected, but it's really difficult to get in there. So let me just grab some tools here. All right. I got some breakout leads here. Let's see if we can chuck that in there and get a proper measurement of the voltage. Alright, I might be able to use that. I'm still trying to get that breakout lead in there. That's the another reason I don't like to do resistance checks. It's just usually very difficult to get in there. Okay, I think I got it now. Let's just do this quick measurement on the resistance. I got my 2 breakout leads coming out of the EGR valve. Okay, so that's what we got here. We got 5, as you can see, maybe there's a little bit of a glare there. So we got 5, exactly 5 ohm on that EGR valve at the moment. Okay, anything else, guys? Any question, any concern, anything? Okay, thanks again. No problem, DJ. Thank you so much for joining in. John, thank you so much. Great class, thank you. Ruben, thanks Japan, learned a lot. Quality of video, everything's done really well. I'll try my best, Ruben, but I'm one-man show here, so I like to have a second person to switch the camera around and follow me around with the camera, but it is what it is. I'll always try my best. Okay, all right, just guys, just give me a thumbs up. That I've heard if you have too many likes on the videos, YouTube trying to distribute it around a bit more. That's what I heard, but don't forget to like, guys. That would really help get some subscribers. Excuse me. All right, guys, no more comment coming through, so I'm just gonna close the session tonight, and I do have one more car outside to do. It's got an ABS light on, so we can diagnose that car. I don't think we're gonna do it tonight. It's getting a bit late, so I'll let everyone have a good night. Maybe tomorrow night I can do ABS light diagnosis. I don't know what's wrong with the car. It's just got the ABS light, so we probably can do that tomorrow night if you got time. But like I said, just turn on your notification on YouTube so you know exactly I will be online, you know, within half an hour and an hour. Usually I'll like to give half an hour, 45 minutes time notification before I go live. So turn on your notification for my channel on YouTube. We can do that ABS tomorrow. Matt has a comment. Let me just throw that out in the... A quick test can be if you remove the EGR, then turn the ignition on and off and see if it is physical cycling. Okay, I'm trying to understand. Matt says a quick test can be if you remove the EGR, then turn the ignition on and off and see if physically cycling. So you mean you want us to watch the valve? Is that what you're saying, Matt? So you want us to watch the valve physically with the ignition on and off. Okay, now that's definitely we can do. We can put powers and earth into that EGR valve and physically open and close ourselves, right? That's no problem. But the problem is not all EGR is going to be in a quick, easy spot. Sometimes you'll be spending hours to get to the EGR. Like one car, remember, which was, what was it? It was a Nissan Navara. I think it's a V6 diesel, and that was a super challenging EGR valve to get it out. So if you got things like that, we don't want to go in there and waste too much time just to do testing. So a lot of the time, without getting into the component, we need to learn how to diagnose before we get the approval from the customer to go in that area and do some testing. If it's right on top of the engine, easy, 2 bolts, 3 bolts, whatever, yeah, we can always do that too. But not always is the case, Matt. So it's good to have a knowledge on how can we tackle without pulling the component out physically. And I know a lot of mechanics that I've worked with in the past and whatnot, and that's the first thing they do. They pull the component out, and You know, personally, I don't think that's the best way to approach a diagnosis on any electrical problems. All right, any question, anything before I turn this off? I'll just give you guys a minute to throw in your last words, whatever, and then we'll probably close the videos. Okay, Joshua has a comment. So you think the motor is faulty? Josh, yes, that's how I practice when it comes to intermittent problem like this. More than likely, as long as the engine, you know, looks clean, no mice, sign of mice been, you know, getting in there, no water damage, or, you know, if the engine, everything looks clean and you got this intermittent issue with the EGR valve, and you do all the circuit testing like a pressure sensor, the control, and everything's there, usually I just throw a new valve. There's not much we can do here at this stage. And usually that's always been the case for me. I've done it quite a few times. If I can't duplicate the fault, do some testing on the wiring and throw a new valve. Okay, before I close the chat and everything, I just want to quickly give you one more tip, okay, that I have, you know, experience, and it's true for many cars I've tested. So let's say, you know, you got an EGR valve problem, and then you run the car. How can you tell if the EGR gas is getting into the engine or not? Okay, can you listen to me again? Okay, you got an EGR valve problem, car come in, and you want to, you know, diagnose the car. Obviously, you just want to quickly verify if the exhaust gas is getting into the intake through the EGR valve, meaning if the EGR valve is opening and it's letting the air, there's no restriction in the piping or the tunnel of the EGR valve, and it's getting into the intake manifold, into the engine. How can you quickly tell that? Okay, so this is what I've experienced. Before I go, last tip, run the car, obviously get it up to the temperature, whatever, not rev it up and down, especially at idle. When the engine is running at its, you know, usual idle RPM, the EGR valve gonna, you know, trying to open and close periodically. Oh, I messed that word up, didn't I? So every now and then, as the car is idling, sitting idling, the EGR valve is going to open and close. at times, right? So whenever the EGR valve opens, what you're going to hear in the engine is the engine notes change. The engine's going to have how can I make this noise? You'll physically hear it like a kind of it will have that tone in the noise of the engine, and as soon as the engine EGR valve closes, the engine noise goes back to the previous stage as in normal. So just look for that next time. Run the car, when the EGR valve opens, it will go like the note of the engine, the sound, the thickness in the sound of the engine changes when the EGR valve is open. That means that EGR gas is getting into the engine. Nothing wrong with the passage. Everything should be, clean. You can assume that. Okay, that's one tip. If you want to quickly verify if the EGR valve open and the gas is getting to the engine. Okay, saying all that, thank you so much everyone. I will catch you next time, maybe tomorrow night. I got an ABS to diagnose. Let's see how it goes here.